Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on astronomy and cosmology from May-June 2022, paper 4, variant 2. In this question, we will talk about Big Bang. We will discuss about Hubble's law, and we will also talk about redshift. And these are three main concepts from astronomy and cosmology. Let's study together. Let's improve together. For our question number 9, part A1, we need to state Hubble's law. Very common question, what is Hubble's law? Let's try to understand what is Hubble's law. Hubble's law simply tells us the relationship between speed and the distance of galaxies. So now you need to understand what exactly speed is. Speed is the speed of recession of galaxies. So v is the speed of recession of galaxies. So simply we can say this is speed of recession. And d is the distance of galaxy away from observer. So this one is distance of galaxy away from observer. So you need to understand how to state Hubble's law in a proper way. So this is distance of galaxy away from observer. Away from observer. And these two quantities, they are directly proportional. Away from observer. It simply means that if d is greater, means the galaxy is far away from observer, it means that galaxy is moving faster as compared with galaxy that is nearby to observer. So as distance increases, speed also increases. Means the recessional speed increases. So the distant galaxies, they are moving faster than nearby galaxies. We can also write down this one in equation form. We can write down v is equal to h naught times d. Let's try to understand what is h naught. H naught is a constant, and this is called Hubble's constant, or simply you can say Hubble constant. We can also call this one rate of expansion of the universe. Rate of expansion means h naught is also rate of expansion of the universe. So simply you can write down rate of expansion of the universe. And we can use h naught, and we can also determine age of universe. So if we need to determine age of universe, we can use h naught and we can determine age of universe. Simply we need to take reciprocal of h naught. According to Hubble constant calculations, age of universe is about 14 billion years. Means 14 times 10 to 9 years. This is just approximate value, not exact value. Now let's try to understand Hubble's law with the help of this graph. You can see on y-axis we have recessional velocity, and on x-axis we have distance. If you look at these distant galaxies, let's say this galaxy, you can see this galaxy is distant galaxy, means is further away from us. It has greater value of distance, and it has also higher value of speed. So simply you can see more distant galaxies, they are moving faster, means their speed is faster. They're moving at higher speed away from us. If you look at closer galaxies, means let's say this galaxy, its distance is smaller and its speed is also lower. So closer galaxies, their speed is slower, means they have slower velocity. And that's all what you need to understand about Hubble's law. Let me show you how you can write down a proper answer. This is how you can write down your answer for this question. So in your answer, you have to mention these parts. In your answer, you have to mention that speed is directly proportional to distance, and this question has 1 mark, and that mark is M mark, mean it has to be in your answer. And the second mark is answer mark. If you have stated what is the speed and what is the distance, you will get the second mark, and second mark is answer mark. So you have to mention speed is directly proportional to distance, you will get 1 M mark. And then if you have explained what is speed and what is distance, you will get second mark, and second mark is A mark. For the second part, we need to explain how cosmology is Scientists use observations of emission spectra from stars in distant galaxies to determine that universe is expanding. Very nice question. So simply question is asking us, how do we know that universe is expanding? By studying spectra from different stars. If you look at these two spectra, you can see we have one spectrum from our sun. Actually, this is absorption spectrum, and we have another absorption spectrum from another star from another galaxy. If you look at these two spectra, you can see they have the same lines, or you can say same number of lines, but only difference between these two is in the second spectrum the lines are shifted towards red end of spectrum, red end of visible spectrum. So you see in our sun we see this line here, but in another star we see this line has been shifted by a certain amount, means it has been shifted towards red end of visible spectrum, or simply you can say in this case wavelength has increased. So lambda of spectral lines have been increased. From here, if the lambda has increased, simply we call this is redshift, and redshift tells us that distant stars, they are moving away from us. So they are moving away from us. So redshift simply tells us moving away from observer, or we can say moving away from our planet. So this is all what you need to write down for this question. So let me show you the answer, how you can write down your answer for this question. This is how you can write down your answer. First thing you can mention is wavelengths of spectral lines are greater than known values. Redshift shows stars in distant galaxies are moving away from us. So this question has 2 marks. The first mark you will get if you have written first point, and that one is B mark. You will get 1 B mark, and the second B mark you will get for the second point. So this is another B mark. For part B, we need to explain how Hubble's law and the idea of the expanding universe lead to the Big Bang theory of the origin of the universe. In Hubble's law, we have already discussed distant galaxies are moving away from us, and they're moving at higher speeds, and closer galaxies, they are moving away, but they're moving at slow speeds. But if we imagine in the past, if we go back in the past, we can imagine a point where all matter must have been close together, and that is called Big Bang theory. Let's try to understand this one with the help of this figure. Now you can see we have these different galaxies, they're moving away from each other, means they're moving away from each other. But if we go back in time, if we go in the past, we can see these galaxies are closer together. But if we go even further back in time, we can see they're even closer together. So we can imagine a point where all the matter must have been close together. That is called Big Bang, and this is representing Big Bang theory. Mean as time is passing, galaxies are moving further away from each other. So this is, we can imagine at time t is equal to 0, then you can say this is time t1, and this is after time t2, and this is what is happening after time t3. So in this case, t3 is greater than t2, and t2 is greater than t1, and this is greater than t0. So this is what we call is Big Bang. Big Bang tells us about origin of the universe. Let's try to write down our answer for this question. This is how you can write down your answer. You have to mention these points in your answer. First point, you can write down all parts of the universe moving away from each other. You will get 1 B mark, and second B mark you will get if you have written more distant objects are moving faster. You will get second B mark, and the third B mark you will get if you have written matter must have been close together in the past. You will get third mark. This is how marks will be awarded. This video is about astronomy and cosmology from May June 2022 paper 42, and the next video also will be from the same paper, and next video will be coming very soon. See you in next video.